Okay, in this PPT, we are going to see about database system architecture. So here, there are four types of users accessing the managing the database. The first thing is naive users, application programmers, sophisticated users, and database administrators. So these four are going to be called as the four users. The database system is again divided into three components. The first component is query processor, storage manager, and next one is disk storage. So the first box, it is going to be called as a query processor. The second box is going to be called as the storage manager, and the last box, that is this uh, cylinder shape, it is going to be called as a disk storage. Query processor, what it will do, it interprets the request or queries from the user via an application program interface. It contains the following components: DML compiler, DDL interpreter, query optimizer, and embedded DML precompiler. Next one is the storage manager. It is an interface between the information stored in the database and the request. It is also known as database control systems. It maintains the consistency and integrity. The main responsibility is managing the data manipulation such as addition, deletion, modification, etc. And the storage manager contains the following components: authorization manager, integrity manager, transaction manager, file manager, and buffer manager. Disk storage, it is used to store all the information. It contains the following components: data files, data dictionary, indices, and statistical data. And data independence, it is an important property of DBMS and also an advantage. There are three levels in the database: physical level, conceptual level, and logical level. Data dependency is used to achieve the changes in the physical level without affecting logical level and vice versa. There are two types of data independence in DBMS: physical data independence, and next one is logical data independence. Need of data independence: to improve the quality of data, easy maintenance of DBMS, to achieve the database security. Developer need not to be very about the internal structure and easily making the changes in physical level to improve the performance. What is physical data independence? It is defined as to make the changes in the structure of the physical level. Some of the changes in the physical level are changing the data structures, changing the file organization techniques, changing the data access method, and modifying indexes. Logical data independence. It is defined as to make the changes in the structure of the logical level, view level, without affecting the physical level. And next thing is, what are the evolution of data models? The important and widely accepted models are hierarchical network entity relationship model, relational model, and object-oriented model. In this hierarchical model, so the best example is clothes. Men and women, they can wear clothes, and men can wear pant and shirt, and vesty and shirt. The women can wear sari and salwar. So this can be easily depicts the, that is, online clothes shopping easily depicts the hierarchical structure. And features of the hierarchy model: one-to-many relationship, parent-child relationship, deletion problem, and pointers. And network model. In this network model, it is an extension of hierarchical model. This model was recommended as the best before the relationship model. Same like hierarchy model: college, department, library, and student. Features of a network model: manage to merge more relationships, more paths, circular linked list. And advantages of network model: data access is faster. Disadvantages: more and more complex in relations. Entity relationship model. This model is a high level data model. It represents the real world problem as a pictorial representation. It contains three components: entities, attributes, and relationship. So this is the AR diagram for the example they have given: faculty and department entity set. Faculty and department. In this faculty ID, faculty name, phone number, date of birth, and salary. All these things are going to be called as the entities, and all these things it is going to be called as the attributes, and faculty will be the entity. And here in this diagram, two entities are there, and the remaining things are going to be called as what? Attributes. And workspace defines the relationship between the faculty entity and the department entity. That's what is being given in this slide. And features of ER model: graphical representation, visualization, and good database design. Advantages: very simple, better communication, easy to convert to any model. And the disadvantages are hidden information. And this is the relational model, widely used model. Data are represented as row-wise and column-wise. So this is the representation of this relational model, and this whole thing it is going to be called as an employee table. And relational model, each row is going to be called as a record, each column is known as attribute, The collection of attributes are called as a record or entity. The collections of records are called as table. In the above example, table is an employee name is a table, and attributes are employee number, employee name, and salary. And next one is object-oriented model. It main example is the class diagram or object diagram. So here three objects like faculty, department, and campus attributes are there. And interconnection link, it is going to be called as a relationship link. And each and every that is class diagram, it contains three compartments. The first compartment will be the faculty, that is object name and attributes and the methods. So this is how we have to draw the class diagram. The degrees of abstraction, the external model is the end user's use of the data. The conceptual model is a database as seen by the specific DBMS. And the goal in designing the internal model is to achieve logical independence, where the internal model can be changed without affecting the conceptual model. And database users and database administrators, name users, application programmers, sophisticated users, then specialized users and standalone users. Name users, those who don't have any knowledge about the DBMS, use DBMS applications frequently. Application programmers, users who develop DBMS applications, they are backend programmers. Sophisticated users having knowledge about the database and DBMS, they can create their own applications based on the requirements. Name users, these are the users who use the existing database applications. They don't write any codes or queries. Specialist users, they are also called as sophisticated users. They will develop the complex programs to the requirement. And standalone users, these users will have a standalone database for their personal use. These kinds of the database will have ready-made database packages which will have menus and graphical interfaces. And the last one is a database administrator. He is a person or a group who define and manage the database in all three levels. Responsibilities of DBA: install the database, upgrading, designing implementation, migrating, user management, backup and recovery. So up to this we have seen about the basic like ER diagrams and the data evolution and evolution models, degrees of data abstraction, and then different types of models. We have evolution of data models we have seen, and in the next PPT we are going to see about like design process. Thank you.